Hello everyone, hope you're doing well. Today again we are here to talk about next topic of system design called partition and sharding. They are very important for scaling the data intensive system. So we'll deep dive. So let's understand what we're going to talk about. So first, of course, we'll understand that why we need to think about these concepts like partitioning and sharding. Then we'll understand more on partitioning, different kind of partitioning like horizontal, vertical, and things like that. Then we'll deep dive into the sharding, why sharding is required at first place. Then we try to kind of compare between these two strategies for where they are fitting, and of course some real world implementation as well. Okay, so let's understand that why even we need to do that, why we need to do partitioning at first place, why it is important to split the data. The reason is that these I would say hardware like storage, memory, CPU, and all, they are not like infinite scale, right? Everything has its own limit can be larger. There's nothing called truly infinite. And how we deal with that constraint and how we make sure that our performance is not dropping and scaling is happening as its space and things are uh, not compromised for user experience, right? So of course, I think we talked about storage limits, that every disk has its own capacity, how much it can support. Of course, you can go till petabyte, but there is always some limit, right? Similar things for memory and CPU as well, that there is always a limit of how many concurrent uh, threads can work at the same time, and same goes with memory as well, that how much data it can store in a RAM. IO is generally a little slower than like memory, but again, it has its own bottleneck, right? It has to kind of back and forth the data in network, so throughput kind of gets impacted. So these things put into us into some kind of constraint, that how we deal with that, how we navigate from these constraints effectively. The solution is like how we can split it. Again, if you want to split within a database, we generally call it partitioning. And if it is across many database instances, then we call sharding, right? So these are two different, uh, you can say sibling of that, which are complementing that each other, right? Uh, so let's go a little more deeper on partitioning, that what exactly it means. So partitioning is about that your partitioning means you're breaking down the bigger data into smaller chunks within the same database, basically, with a goal of having faster queries. uh, Retrieval is faster, maintenance is easy because you're dealing with not like entire database, but part of it. And basically your access become faster, and that's one of the important goal for any system, that your queries are faster. uh, there are some ways to how we can do that, but yeah, partitioning is one approach which is pretty popular in database world, which you can think about in improving performance in case your database is super heavy and you want to you want some kind of optimization there. But again, there are strategies around partitioning. So yeah, you got to understand that what should be a partition key and things like that. Bad partition can ruin your experience, right? So partitioning is a good way if it is done efficiently. So you got to see that how you know uh, how you're going to do that. So please read about it, that what are the different effective strategies about partitioning. Now, partitioning has its own flavors as well, that you want to do horizontal or vertical. Uh, so if you say horizontal, basically what you're saying is, sometimes we also call it uh, horizontal partitioning as a sharding, where you are kind of adding different nodes for different kind of data without necessarily to have a downtime. And vertical is something that basically you know uh, you are basically has the different way to look at is that, For example, you're saying horizontal, so there is a row and you're breaking it down into columns. If it is vertical, you are so so you can imagine that how you're partitioning. So basically, if it is a horizontal, what you're saying is that each partition has all columns but only subset of rows. So you're doing like this, right? You're doing like this. Vertical partitioning, you're going like this. So each partition has all rows but basically subset of columns. So there are different ways to do that. You might have heard about columnar database or things like that. So those kind of different strategies that that you can use. When you say sharding, don't get confused. The concept you can relate a bit, but sharding typically means that you're doing partitioning of this kind in different servers. When we are doing this on the same server, then basically we call it partitioning, right? So if it is a different servers doing the similar thing, we can call sharding. So this is how it is. Again, there are different ways to do that. You can have a range base that you can say that, okay, for these kind of range, for these dates, you can have a partition based on different timestamp. You can have some hash function as well, some modular function you can use. Of course, you can have some list, different categories and things like that. So there are different ways to do that. You got to understand that which is really, I would say, matters to you, or which can be good fit for you. You can read through more about it, that what will happen if I do this versus that. But yeah, I think the recommended way that start with something easy and then you kind of optimize this as you progress. Now let's dive into the sharding. So we kind of understood that if you're vertically or horizontally, like vertically or horizontally, you are partitioning in one server. Typically you call it partitioning, but if it is across different nodes, we call it sharding. So they're kind of similar concept, but it's about a scope, right? If you're doing in a same machine, then you end up telling is partitioning. But if it's across different machine, you call it sharding, just to have a differentiation. Okay, so as you can read that it is distributing data across multiple servers. So the thing is that if the system is kind of like maybe high throughput systems, or the users are growing like exponentially, same server can put us into a constraint, and it's hard to scale beyond certain threshold, right? So then you got to kind of span different nodes. You can't just live with a one node. In those cases, you got to kind of distribute data among multiple servers. So you have a load balancer where you get different shards. Basically, they're the instances. You can call it database instances or data instances, different nodes. They keep different kind of data, right? Again, it adds a complexity, but sometimes you have no choice but to kind of data is really huge, and you got to have different shard which are supporting a kind of partitioning, right? But yeah, they are different shards, right? Horizontally scale. So you got to kind of do that. But there are ways to handle that. There are ways to handle the challenges and kind of not bottling, but basically overhead, so that you end up getting good performance while you're distributing your data across different multiple servers using sharding. Again, there are strategies, right? Similar thing. We can have a range-based hash rates. There are pros and cons of each, but again, you got to see that which is really, which is really kind of useful for you. I have seen people start with maybe range or hash to begin with, and they kind of uh, extend it or make it more complex as they progress. Again, you might have heard about this term consistent hashing. That is to kind of address this when address a constraint about uh, downtimes, right? So without necessarily making the system down, you're adding a new shard, right? If you're just doing a regular sharding, it's really hard, and generally you don't achieve that. There will be some downtime, when you add a new node. But if you have a strategies like consistent hashing, it's like you can imagine like a ring where you can attach a new instance, and without necessarily kind of making the overall system down. Of course, you got to kind of locate and copy and all that in the background, but basically the main goal is that you're not keeping the system down. You can use hashing kind of approach. There are more to it, but yeah, I think I'm giving you a high level, but yeah, you can go through more, understand more about it. Now, what's let's say talk about summary, right? I think what's different. So I think we talked about that if it is within database stance, your partners, you're kind of breaking down, chunking. We call it partitioning. If it is across multiple database servers, you call it sharding. Of course, limited server, right? Single server, you need to rely on that. You can't go beyond. In true horizontal, you can keep adding servers, but again, if it is a consistent hashing, you can keep adding server without making the system down. That's even recommended approach. Of course, complexity. If there are multiple servers, you got to have a distributed system kind of thing you need to look at, because systems are connected, and at times they may have downtime. So you need to look into that, how efficiently you are mitigating that constraint. Of course, partitioning is vanilla partitioning is simple because you're just dealing with one database. Join will be faster in partitioning. Sharding may not be that faster, but again, you need to look into different strategies, that how to keep similar data into one shard so that you can minimize the load on cross joins kind of shard, right? So there are ways to handle that. There are ways to address it to the extent. Of course, consistency, if it is one server, it is easy to kind of have this CRUD kind of operation, easy to achieve this strong consistency. If it is sharding, generally, you look for eventual consistency because your data is on multiple machines, not just one. So yeah, you kind of decide that, and you accordingly you kind of deal with that, whether you want to partition or sharding. So we discuss about when you should use one, and accordingly we'll decide that. Okay. There are some real world scenarios that you can look into which are using these approaches. And takeaways, again, start simple. When you're getting complex, you kind of extend it, and keep monitoring how this goes, and then you can deal with that. Okay, that's what a quick overview about partitioning and sharding. Hope you liked it. Thank you. Take care.